Hi, my name is Nikolai Onken from Yuxibu, and today I would like to show you how to use dtrace with JavaScript. If you read the blog post, you might have seen already a few simple dtrace scripts which allow us to profile and debug our JavaScript applications. So here I would like to show you how to profile function execution time and display that execution time in a nice chart. So let's take a look at our dtrace script. Here we see a couple of files, and the most important file at the moment is the function underscore time.d. Let's take a look at this. Now this is a simple dtrace script. What we see here is two probes. The first probe gets fired every time we enter a JavaScript function, and the second time every time we return from a JavaScript function. So the only special thing here is that we only would like to let these probes get fired when they match, or when the function names match the first parameter passed to the script. So this will allow us to only trace very specific function calls. Now what we do in the function entry probe is we assign a timestamp in nanoseconds to the TS variable, and in the function return probe we aggregate, or we create two aggregates. The first aggregate is the times aggregate, which creates an average of each function execution of that specific function, and the second aggregate is an aggregate over the times a function got executed. At the end of the function return we assign 0 to the TS variable to free up some memory. So let's see how this dtrace script will perform. If you want to start a dtrace script, you always have to use the s parameter and execute it under root permissions. As a second argument, we pass the file we would like to execute, which is function time.d, and now, as we have seen in the script, we need to pass in a function name we would like to analyze. So let's take a look at our little example here. What we will do, we will compare appending nodes to the DOM, and there's two ways we will do that. The first way is that we will append these nodes within a while loop and add them to the DOM within the while loop, and the second one is that we will append those nodes not to the DOM but to a document fragment within the while loop, and then after the while loop has been executed we append that document fragment to the DOM. The second one is more performant, and we will see the result in a second. So here we see the code, function run tests, which will run the test 10 times, and we have two tests, test fragment and test default, and we would like to analyze the test default function first. So we pass this as an argument, and then we want to write the output to the data dtrace file. We see the script matched 4 probes, and now we can start the profiling. This is going to take a few seconds. Here we go, test is complete. The first dtrace test can be closed, and now we do the same for the test fragment function and append the data to the data.dtrace file. So here we now execute the second test. Test complete. This is already it. We have run our tests, we have written them into a data file, and now we can visualize these data in a nice DojoX chart. So let's take a look at this little application we have written to give you a better impression on the application performance. Here we see the chart, the two functions we have profiled, test default and test fragment, and now when we look at these we see they have different execution times. The test fragment was executed in 252 milliseconds average, and the test default in 260 milliseconds. So we see you can create more performant applications using document fragment. There are several blog posts about this. This here is just an example so you can see what the difference is. Now in the next videos and blog posts I will show you how to get more view of your application performance and how to use more involved dtrace scripts to really get a deep insight into your application. Thanks for watching and hope to see you soon again.